To most of us, the age of dinosaurs is defined by sheer earth-shaking scale. We picture massive apex predators with jaws large enough to crush cars, dominating the landscape through brute force. But the biological dynasty that ruled the planet for 160 million years didn't begin with a 40-foot carnivore. It started with an animal completely opposite in size and ferocity. Meet Eoraptor, the dawn plunderer. Next to the iconic giants that would follow it, this early dinosaur was roughly the scale of a modern beagle, darting through the underbrush rather than stomping over it. While it appears insignificant, this animal combined the predatory mechanics of later carnivores with the lightweight frame needed to navigate the Triassic. Its anatomy provided the template for a body plan that would eventually support the largest land animals in history. To track how dinosaurs actually conquered the globe, we have to look past the later heavyweights and examine the highly adaptable, lightweight anatomy of this Triassic pioneer. This diagram compares the Eoraptor to a modern dog for scale. From its snout to the tip of its tail, it measured about 3 feet long, and it weighed only between 10 and 22 pounds. That low weight was driven by its hollow bones. By shedding heavy internal bone mass, Eoraptor could maintain an upright, bipedal stance, using its long hind legs to reach sprinting speeds to escape larger predators. This graphic illustrates a distinct quirk in its hands. While it had 5 fingers, the 4th and 5th digits were tiny, vestigial stubs, appendages that have lost their original function. The animal relied entirely on its 3 primary elongated claws for snatching up meals. A lightweight, hollow-boned frame, a fast bipedal posture, and specialized grasping hands. These mechanical advantages provided the foundation that later predatory dinosaurs would inherit and scale up. Today, the Esquialasto Formation in northwestern Argentina is a dry, barren expanse of rock and dust. But 231 million years ago, during the Late Triassic period, the supercontinent Pangaea looked very different. This exact spot was a warm, intensely humid river valley, packed with towering trees and giant ferns. This fossilized Eoraptor skull reveals clear variation in tooth structure. The broad, leaf-shaped front teeth were designed for snipping vegetation, but the back teeth are sharply curved and serrated, ideal for slicing through meat and insects. By functioning as a true omnivore, Eoraptor could eat whatever the environment provided. This flexibility allowed it to remain active during seasonal shifts, outcompeting rivals that relied on a single dwindling food source. The discovery of this species happened almost entirely by chance. In 1991, an Argentine paleontology team led by Ricardo Martinez was conducting a search in the desert terrain of the Esquialasto Formation. After weeks of turning up empty-handed in the heat, Martinez noticed a small, unremarkable rock on the ground. He picked it up, inspected it, and actually considered tossing it aside. A single detail caught his eye right before he threw it. Protruding directly out of the gray stone were the distinct, sharp ridges of fossilized teeth. When researchers finally brought that unpromising rock back to the lab and carefully cleared away the dust, they found something incredibly rare. Inside was a nearly complete, perfectly preserved skull of an Eoraptor. This single specimen provided the anatomical evidence for the transition from small, generalized runners to the specialized giants of the Jurassic. It shows how the skeletal groundwork for these towering behemoths was laid millions of years earlier. The 160-million-year dynasty of the dinosaurs ultimately required a highly adaptable pioneer. Before the giants could shake the earth, a fast, hollow-boned omnivore had to first survive the dense forests of the Triassic.